I also want to take some time to look at something called percentile. I know most of you have heard percentile used plenty before for situations like your ACT score is in the 75th percentile, or a person's body mass index or BMI is in the 99th percentile. But what do those mean? Percentile is the percent of values at or below a specific value. So if you looked at your ACT score is in the 75th percentile, that means 75% of people who took the ACT got the same score you did or lower. How you can calculate percentile, I'm going to actually write this neatly. Percentile is just the number of values at or below the given value divided by the total number of values in the data set. So if we're talking like ACT score, there's going to be how many hundreds of thousands of high schoolers who take the ACT each year. So then that would be your denominator. And then your score, say you got a score of 25, then your percentile would be you add up all, or you count how many scores were from 0 all the way up to and including 25. You're counting those values. Let's do some examples. So I'm going to go back to this same money in the wallet for Irondale staff. And we have these 40 values. So we have 40 total values in our data set. And we're asking what percentile is $50. Well, that percentile, so the total number of values in the data set is 40. So then our numerator, we are going to count all the way up to and including $50. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 out of the values in this data set were at or below $50. And then we just do that division. 19 divided by 40 is 47.5. Well, that's 0.475. And we could say the 47.5 percentile. If you wanted to round that to a whole like percentage, that's okay, because it's really weird to go a decimal percentile. But that's what we're looking for. So let's try this other one. Let's see, blue would be a good color there. What percentile is $36? So we need to erase those, clear that off. And we do the same idea. So with my data set, thankfully, I already arranged them least to greatest. But if your data is not that way, then you'd need to do that. What percentile is $36? So 1, 2, 3, 4, 5, 6, because we're counting $36. So it is 6 over 40. We put that in our calculator. That is 0.15. So that is the 15th percentile. And this idea can work in reverse as well if we look at question C here. It says how much money represents the 80th percentile. So let's go to red here. So we know the 80th percentile And we know we have 40 numbers in our data set, so we're looking to find this up here. So let's do that. We do the algebra to multiply both sides by 40. So 40 times 0.8 is 32. So x equals 32. But that's not $32. This is how many values we have to count. Because remember, percentile is the number of values that are at or below a specific value. So we need to count up 32 numbers to find how much money. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each row is 10, so that is counting up 20 values, counting up 30 values, 31, 32. So that means $70 is how much money would represent the 80th percentile. So if you had $70 in your wallet or billfold or purse or satchel, then that would put you in the 80th percentile of Irondale staff members. So that is how we calculate percentile or find percentile values if we're given the raw numbers. But what if we're given a histogram? So this histogram gives our information in a slightly different way than the raw data set. This specific example here says the histogram below shows the number of texts students sent each day. Well, this has got to be from 15 years ago then, or it was sampling a really weird group of students. Anyways, this first bar here is from 0 to 2. So that means that it's going to be 0 to 2, 0 to 2. But this one here can't be from 2 to 4 because then 2 would be double counted. So the values that are in here are going to be 3 to 4. The values in here are 5 to 6. Values in here are 7 to 8. Values in here are 9 to 10. So it's not, this way of representing this data was not perfect, wasn't great, but it shows you the upper boundary of each of these frequencies. So let's start looking at this data a little bit more. So this frequency from 0 to 2, there was one student, but we don't know if that student sent 0, 1, or 2. In this bar, the frequency is 3, and they sent 3 to 4. This one here, the frequency is 4, the frequency is 4, the frequency is 5. So if we wanted to, we actually could take this a step further, and this is kind of a hack. We can calculate what percent of the data is in each of these frequencies already. This will be kind of a shortcut. So let's see, we have 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus 5 is 17, so 17 total values, which means 1 divided by 17 is 5.8%. Let's make this nice. I'm going to round this to 6% of our data is there, which means we multiply that by 3. So that means that is going to be 18%. That is 24%, 24%, and then 30%. So that's what percent of our data, give or take my rounding, what percent of our data is in each one of those frequencies. So if we want to know the percentile that 4 text messages would be in, we're going to go to this spot here. So if you sent 4 messages, that would mean that all of these values are less than or equal to 4. So there were 4. We don't know what number is actually in this frequency. We don't know what numbers these are. These, in this bar here, all of these could be 2 or they could all be 4. We don't know. But we do know that they are not bigger than 4. So then our percentile would be 3. It would be 4 out of the 17 total values. And since we already found the percentage in each of these groups here, we can just add those together. So that is 24. So about 24%. 24th percentile. So it's an estimation because histograms are inherently a flawed way of representing data, but it's a quick way to get some idea. So if you are sending 4 texts each day, you're in the 24th percentile of high school students. Although it just says students, yeah. Well, what if what percentile is with 7 texts? Well, we've got a problem here because 7 isn't one of these boundaries. 7 is in this region here. And from histograms, from frequency distributions like this tells us that we have 4 values in here that were 7 or 8, but we don't know. They could all be 7, they could all be 8. There could be some way that they're split up. So we don't know for sure. But what we can do is we can approximate it. And the way that we're going to approximate it is we're just going to cut this one in half. We're just going to guess that it's reasonable that half would be 7, half would be 8. So then what we can do is we're adding this stuff all together. We could add the values. 1 plus 3 is 4, plus 4 is 8, plus half of this would be 2 more. So that would be 10 out of 17. Or we can do it with the percentages. So we're adding 6% plus 18 is 24, plus another 24 is 48, plus another 2 is 50. So that is approximately the 50th percentile. And again, it is really important that you note that this is approximate. When we have a value that is not clearly able to count how many are at or below, when we have a frequency table or a histogram where we're just given how many are in that range, you need to make sure that you are letting your teacher know, letting your audience know that it is approximately, because we don't know for sure. It would change the results very much if all 4 of the values in this class, in that space right there, were 7s, or if they were 8s. It would change your answer a lot. So you have to say approximately. That's being a good statistician.